Well, good morning. This is Ms. Billerbeck, and we're going to talk about greatest common factor. So the greatest common factor, GCF is how it's abbreviated, of a group of numbers is the largest positive integer that can divide all the numbers in the group. So first we need to figure out, well, what are the factors of 18? So we know 1, 2, 3 is a factor of 18. We have 6, and we have 18. So we know 1 times 18 is 18. Oh, I've forgotten a very important one. Let's put in 9 and 18. So 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is 18. So let's look at the factors of 24. So we have 1, 2 also goes into 24, 3 goes into 24, 4 goes into 24, 5 does not, but 6 does, 7 does not, but 8 does. So now let's talk about, well, 1 times 20, or let's see, 4 times 6 is 24, 3 times 8 is 24, 2 times 12 is 24, and 1 times 24 is 24. So we have the factors of 24. So our common factors, so let's circle those. So we have common factors, well, 1, we have 2, we have 3, and we have 6, and that's it. So our common factors are 1, 2, 3, and 6, but the greatest common factor is 6. All right, so that's how we can find the greatest common factor. So let's look at finding the greatest common factor of 252. Well, let's just start with a factor tree. Whoops, that's 252. Well, it's an even number, so that's easy. We know it's divisible by 2. So when we divide this by 2, we have 1, 2, 6, and it's divisible by 2 again. When we divide that, we get 6 and 3. Well, we know that this is not divisible. Well, 6 plus 3 is 9. 9 is divisible by 3. So this is divisible by 3. So that gives us 21. 2 plus 1 is 3. That's also divisible by 3. So this is divisible by 3. And we get 7. So our prime factorization for 252 with exponential notation, we have 2 2's, so that's going to be 2 squared times 2 3's, 3 squared times 7. All right, well, let's look at 360. Well, it's even because it ends in a 0. So let's take a 2 out. And 2 into 3 is 1, and then that's 16, so that's 8 and 0. It ends in 0, so it's divisible by 2. And we get 90. It's divisible by 2 again. And that ends up, that 2 goes into 9 4 times with a 1 here. 2 goes into 10 5 times. So 4 plus 3 is 9. 9 is divisible by 3. So we divide by 3, and we get 1, 5. 1 plus 5 is 6. 6 is divisible by 3, so this is divisible by 3, and we get 5. So this one prime factorizes as we have 1, 2, 3 2's, so 2 to the third times, and there's 2 3's, so 3 squared times 5. All right, so now that we have those prime factorized, let's write them out and see what is the greatest common factor. So let's write them one above the other. Maybe we can see it a little more easily. 152 equals, and then I'm going to expand this out. Times 7. Let me really expand this out. So times, and then I'm going to leave some spots here. But there's some method to my madness, so just hang in there. Actually, this one's going to be way over here. Okay, so we have 252, and then we have 360. So when we expand this out, we have 2 times 2 times 2 times 3 times 3 times 5. So now what we can do to find the greatest common factor with numbers like this is we see, well, they both have 2's here and here, and here. They have 3's here and here. Okay, so now we need to figure out, well, what is 2 times 2 times 3 times 3? Well, that's 4 times 9, and that's 36. So 36 is my greatest common factor. So this equals the group GCF. All right, let's try a different one. All right, so first we're going to factor 154. So 154, and it's divisible by 2 because it ends in an even number. I'm going to save a lot of room here. So we have 7 and 7. So 7 times 2 times 77 is 154. Okay, so that's not, 7 plus 7 is 14, not divisible by 3. It's not divisible by 5 because it doesn't end in a 5 or 0. So our next prime number is 7, and it does go into that. So we have 7, and then we get 11. So this prime factorizes as 2 times 7 times 11. All right, let's look at 330. Okay, so it ends in a 0, so we can take a 2 out. And then there's 1, 2, and 3. And there are 6 2's and 13 with 1 left over, and 5 2's and 10. So 1 plus 6 plus 5 is 12. 12 is divisible by 3. So we can take a 3 out of here. It's not even, so I did not try to. So 3 into 16, that's 5 times. Carry a 1. 3 into 15 is 5 times. All right, so 5 plus 5 is 10. That is not divisible by 3 anymore, but it is divisible by 5 because it ends in 5. And we get 11. So this prime factorizes as 2 times 3 times 5 times 11. All right, let's look at 396. All right, so it's an even number, so we divide by 2. And then we have 2 into 9. Our 2 into 3 is 1, carry a 1. 2 into 19 is 9 times 8, and that leaves 1 over. 2 into 16 is 8. We have another even number, so we take a 2 out. 2 into 19 goes into 9 times, leaving 1 left over. 2 into 18 is 9. So we can try 9 plus 9 is 18. That is divisible by 3, so we can divide by 3. When we do that, we get 33. 3 plus 3 is 6. That's divisible by 3. So we can take a 3 out, and we get 11. So this one prime factorizes. I'll write it here really quickly. So when I erase, I have it. 2 squared times 3 squared times 11. Okay, so we did our hard work having lifting here. So let's go ahead and erase these trees. All right, so let's rewrite these numbers so we can see what our greatest common factor is going to be. Da, da, da. So we have 154. And that's 2 times, there's no 3's. We have 2 3's, so let's leave some spots here. And then we have a 5 coming up, so we're going to leave another spot there. We have a 7, and then times 11. All right, 330 equals, and we have 2 times 3. There's not another 3, but there is a 5 times and 11. And then 396, we have 2, oops, I didn't have room for that one. 2 times 2 times 3 times 3 times 11. Okay, so we look for what is common. Okay, so they all have a 2. So we can circle the 1, 2 that they all have. They don't have 2 2's. Not all of them have 3's. 154 does not have a 3 in there. They all don't have 5's. They all don't have 7's, but they all have 11's. So our greatest common factor is going to be 2 times 11, which is 22. So that's how you find a greatest common factor with prime factorization in exponential notation or just expanding. All right, let's do a real life example. So we have a rectangular piece of paper measuring 35 centimeters. Mustn't forget my units there. And 28 centimeters. It's always good to draw. Draw a picture is worth 1,000 words. So when we have this, we want to cut identical squares. What do we know about squares? We know their sides are the same. The lengths of their sides are the same. So we need to find a common length. So find the largest possible length of a side of each square. All right, so let's factor 28. So it's even, so we take 2 out, we get 14. We take another 2 out, we get 7. So we factor 35. It's not even. 3 plus 5 is 8. That's not divisible by 3, but it ends in a 5. So we can take a 5 out, and then we have 7. So we see what they have in common is this 7. So 7 is the greatest common factor. So the largest possible side is 7 centimeters. And that would be the largest side of the square. All right, that's it for section 1.3. Have a wonderful day.